Okay, so we're gonna start going over these. Alright, so it says to express the log as a single logarithm. Right? For ones like this, you could also, let's say you got stuck and you didn't remember what to do. If you can evaluate the logs in your calculator and you would get the same decimal as the answer, you could check that way. So I'm going to show you how to check that as well. So when you're writing as a single logarithm, you want to look for numbers in front, because if the number's in front, then where does that go? The exponent. So this is going to become an exponent. If you have minus, what does that mean? Divided by. So this is going to be log base 4. And then if the 2 becomes the exponent on the 3, it's going to be 27 divided by 3 to the power of 2. Well, 3 to the power of 2 is what? 9. So this is log base 4 of 27 divided by 9. What's 27 divided by 9? 3. So it's log base 4 of 3. Now, if I wanted to check that, if you have the TI-84 where you could actually put the base in, then you'd be able to find that. So if you do the log base, so 4 of 27.
How do you get the log base?
That, so you go to math, and then you're gonna I arrow up because it's towards the bottom, and it says log base right on it. So math, and then if you arrow up to log base 4, 3. Okay, so this is the decimal you get when you do the original problem. I said that that's the same thing as log base 4. So, yeah. So it'd be 4, 3. And then see, those match, so I know that F is the correct answer. Now, if you don't have the log base, remember you can always do the change of base formula. So if you have log base 4 of 27, that's the same thing as the log of 27 divided by the log of what?
3.
No. So the change of base formula says this is the same thing as the log of 27 over the log of 4. Right? And then you would subtract 2 times, this would be the log of what over what? For this one. If it's log base 4 of 3, it's the log of what? As if you aren't going to participate, I'm not going to do this whole thing for you. I just showed you how to do the change of base for the first one. This would be the log of 27 over the log of 4. So for log base 4 of 3, this is going to be the log of what? How do you find it?
Oh, log 4.
Yep, the log of 3 divided by the log of 4. Okay, so you could still find it that way. Okay, and you'd be able to check. For 2, you're simplifying the log. If you can't see the base on the log, what is it? 10. If you have a log base 10 and you have an base of 10 with the exponent, those are going to undo one another. And it's the same thing if you have a base of 10 and then the log base 10 is in the power, those are going to undo one another. So this is going to be 36 minus 2 times 12. 2 times 12 is 24, so 36 minus 24 is going to be 12. Okay, this is which is equal to log base 6 of 42. This is what I just talked about in number 1. So your change of base formula. If you have log base b of x, the change of base formula says you can do the log of x divided by the log of b, because you're changing the base of these to 10. So if we use that rationale to do log base 6 of 42, that's going to be the log of what on top? 42. And then I always remember the base is on the bottom. So it'll be the log of 42 over the log of 6, which is going to be A. Okay, for number 4, it tells you to solve. What you would want to do first is you want to make sure that you can't write it with the same base. So I can rewrite 4 with a base of 2 because 2 squared is going to be 4 and everything else is going to stay the same. Can I rewrite 32 with the base of 2? So you can't divide it because it is an exponential function. If it was times, then you could. So 2 to the 5th is going to be 32. Now, if bases are the same, what do we know about the exponents? They have to be equal to. So then I can distribute. So 2 times 4x is 8x. 2 times negative 1 is negative 2. And then this would be 10x minus 5, and then I could solve for x. So I want to get all my x's on one side, all my numbers on the other side, and I get x is 3 over 2. Now if I want to check that, I can plug that back in and make sure that those are equal. So this would be 4 to the power of 4 times, and then this would be 3 over 2, so I'd have to put that in parentheses, minus 1, and that gives me 1024, so let's see if that happens over here. So this would be 32 to the power of 2 times 3 over 2, minus 1, 1024. So see how those are equal? Then we know that 3 over 2 is the correct answer. So technically, if you forgot how to do this, what could you do with the answers? You could plug them in and check and make sure that they're equal on both sides. They just have to equal the same number. Okay, for 5, I have a base of 3 and 100. Can I rewrite 100 with a base of 3? No, so then I have to use the inverse. What's the inverse of an exponential function? A log. So when you do the log of both sides, remember that one of our properties of logs is when we take the log, what happens to the exponent? Good. Okay, so then when I take the log of both sides, I'm going to have x plus 1 times the log of 3 equals the log of 100. And then if I want to get x by itself, I divide both sides by the log of 3. And I actually wait to do all my calculations at the end. So I have x plus 1 equals the log of 100 divided by the log of 3. And then my last step would just to be to subtract 1 from that. So I do have to use my calculator to evaluate the log. So it's log of 100 divided by the log of 3. Okay, so I get 4.19, so then when I subtract, I'm going to get 3.19. Okay, now for the next one, natural log and e are inverses, so they undo each other. But here, see how there's that 2 in front? They have to be right next to each other in order to undo the operation. So remember, if you have a 2 in front, where can we put that? It's the exponent. So this is the same thing as e natural log of x squared. And when you rewrite that, now you could cancel these out. So I'm left with x squared in the first term and x in the second. So it would be x squared plus x. You can't combine those together because these are not what? Yeah, they're not like terms, right? You have an x squared and then an x. This says evaluate f of 10. All we're going to do is plug 10 in for x. So if we do the natural log of 10, we can do that. We're going to have to evaluate the natural log on our calculator. So the natural log of 10 would give us 2.30. For the next next one. If the data below is from an exponential function, what's the value of a? If it's an exponential function, you have to have the same ratio. So if it's the same ratio, it's going to be a over 4, and that would have to be equal to 10 over a. So the ratio is always the second term over the first term, the second term over the first term. And then if I have a proportion, how can I solve this? Yep, so a squared would equal 40, and then I'd have to take the square root. What do we look for in the square root? If we're going to simplify this, we need a perfect square, right? What's the perfect square? 4. 4 times 10, and then the square root of 4 would be 2, so it would be 2 root 10. Okay, so then that would give you a constant ratio. 9, which of the following functions is an example of exponential decay? For exponential decay, the base has to be in between 0 and 1. Well, how do you know which one's the base? It's attached to the exponent, yes. So this is the base? Nope. This would be the base. It can't be the variable. This is a log, so that's definitely not going to work. This is the base here. It's in between 0 and 1. That's why it's going to be b. Right? So this says you have the rare postage stamp for 5,000. It increases in value by 11%. In general, your equation for this is a 1 plus r to the t power. So a is your starting amount. If it increases, it's plus. If it were to decrease, it would be minus. And it says for 10 years, so now we're going to plug 10 in for the time. And for 10, that would be g. Okay, so 11, this is another one about the exponential function. What is the value of the constant ratio? So remember, like I did before, you're always going to take your second term and divide it by the first. So this would be 1 divided by 1/4, and that should be equal to 4 over 1. And then can you guys tell me what the next ratio would be? Okay, good. And then the last one? Good. And 1 divided by 1/4 is like 1 times 4, so this would be 4. 4 divided by 1 is 4. 16 divided by 4 is 4. And 64 divided by 16 is 4. So it would be J. Okay, so which equation is best represented by the statement x varies directly with y and inversely with the square of z? So if it varies directly, remember this is direct variation, this is inverse variation, and this is joint variation. So if it is directly with y, that means it says x varies, so x would equal, and it varies directly with y, so it would be x equals ky, just for that part. And then it says inversely with the square of z. So if it's inversely, that's going to be divided by, and if you square z, you would just have z squared, and you do have to make sure that you have your k there. Okay, so then this would be a. Okay, for 13 it says p varies directly with q and inversely with r. So p is going to vary directly with q, inversely with r, and p equals 12 when q is 8 and r is 6. Find p when q is 3 and r is 4. Okay, so first we have to go ahead and solve here for k. So we'd multiply both sides by 6 and then divide by 8. So you get k is 9. So then you can plug that in to find p. So it would be 9 times, and now our q is 3 and our r is 4. So that would be 27 over 4. Okay, so 4s gonna go into 27 6 times with 3 left over. So 6 3/4 or 6.75. Okay, for 14, 15, 16, we worked on those yesterday where you have to factor. Okay, so you're going to factor the top, you're going to factor the bottom, and then you're going to have to cancel those out. Okay, so you are going to factor those and then cancel out what they have in common. I'm going to kind of skip around so we see some that are unlike what we did yesterday. For 18, that would be a good one. Which of the following was equal to this here? So you could get a common denominator and solve it that way. Do you guys know something else you could do to check? It says which of the following is equal to? Yeah, plug in a value for x. So if you plug in any value for x here, like if we do, let's plug in 4, okay? If we plug in 4, this would be 1 plus 1/4, which is 1.25. If we plug in 4 here, what's 1 minus 1/4? Yep, good. Okay, so let's divide those and see what we get. 1.25 divided by 0.75. You get 1.6 repeating. Okay, if I were to plug in 4 here, I should get the same thing. Okay, so if you plugged in 4, you'd have 5/3. 5/3 is 1.6 repeating. That is going to be your correct answer. If you did that with these, if you plugged in 4, you'd have 3/5, which is not going to be 1.6 repeating. Same thing here. If you plugged in 4, this would be 15/4. And that would be 3.75, so that's not going to work. And then this one wouldn't work either. Yeah, Alex?
I remember that the direct and inverse radiation equations, but I feel like there was another, there was joint, what was that?
Yeah, joint, inverse, and direct.
What was the equation for joint?
Right here.
Ah.
Yeah. Yep. What's that? Right. Yeah. All right, and then 19. This is one that we didn't do, so this is going to be kind of like a bonus question for you. It says identify all the asymptotes of this. To find the asymptotes, all you have to do is set the denominator equal to 0 and then solve. So if you set x minus 1 equal to 0 and solve, that's going to be your vertical asymptote. So what is my vertical asymptote for this? How many answers have that? 1. Only this one, right? Okay. The horizontal asymptote, if these are the same degree, it would be like 2x over x, and the x's would cancel out, and you get 2, so it would be y equals 2. Okay. But like I said, that'll be a bonus question for you. All right, we're gonna go over 23.
Is there ever part on this test where I can't use a calculator?
No.
I don't like that one.
Okay, so for 23, this is what was given to you. We went over one like this yesterday. 2 minus 6 is -4, so to make it positive, it goes on the top. -5 minus 1 is -6, so to make it positive, it's going to go on the bottom. And sorry, I think I said the top, but I meant the bottom here. So this will be your final answer. Which one?
22.
Oh yeah, okay, so working alone, Sam can paint a room in 5 hours. What you're doing is you're using this formula, distance equals the rate times time, to set this up. So if Sam can paint it in 5 hours, his rate is 1 room in 5 hours. Okay, and then what you have to do is multiply that by the time it takes them to do it together. So the time it takes them to do it together is going to be 3 hours. Now we don't know what Mike's rate is, so it's 1 over H, but we do know that the time it took them together was 3 hours, and that was going to equal 1 because it's 1 complete job. So this is how you would set it up. If you multiply those together, you'd have 3 over 5 plus 3 over H equals 1. And then you could multiply by the LCD. So multiply every term by the LCD in order to get rid of the fractions. So when you multiply this by 5H, the 5's cancel out, and you have H times 3. For this one, the H's cancel out, so you'd have 3 times 5. And here you'd have 5H. So then you'd want to get all of your H's on one side. So if you subtract 3H from both sides, you'll have 15 equals 2H. Divide by 2. And then H would equal 7.5. Remember, that's going to be in hours. So if you have 0.5 hours, how many minutes is that? 30 minutes, half of an hour. That's why it'll be C. All right, I'm actually going to go to the last page to make sure we're good on that. Okay, so do you guys remember how to find the value of the cotangent?
Isn't that like 1 over the...
Yeah, exactly. So remember that they're the reciprocals. So if the tangent of theta is O over A, the cotangent of theta is what? A over O. So this is your theta. This is going to be your opposite side. This is your adjacent side. So it would be 3 over 4, which is going to be A. So A over O would be 3 over 4.
Can you go over the probability stuff? I think we're good with like this stuff.
Yeah, what about like 46?
That was 46, we should go with
That, oh, I'll also, okay, so for this one, what you're trying to do is you're trying to find where is the sign root 2 over 2 on the unit circle. And if you know the first part of the unit circle, you know that root 2 over 2 is going to happen at 45 degrees. And 45 degrees is the same thing as what?
Pi over 6.
Nope.
Pi over
Yep, because this one's in the middle, right? Remember, this is root 2 over 2 and root 2 over 2 here at pi over 4. So it'll be pi over 4 plus 2 pi n. The other place where that's going to happen is right here. If this is 1 pi over 4, this is 2 pi over 4, this is 3 pi over 4. Okay, I'll also show you a little something. So let's say you want the answer in radians. If your mode is in radians, and you do the inverse sine of root 2 divided by 2, okay, you get 0.785. If you do pi divided by 4, it's going to be the same thing. Okay, now if there's 2 of them with pi over 4, you still have to know where the other one is. So, yeah, so you are welcome to have your, if you want to put your unit circle on there, you can, that's fine. Or even just the first one. So you guys are saying that we should go over the probability stuff again?
Yeah.
Okay. So starting with like 58.
No, I got
Okay. Oh yeah. So a coin is flipped 4 times. What's the probability the result is heads all 4 times? So what's the probability that he gets heads on the first one? 1/2. What about the second one? 1/2. The third one? 1/2. The fourth one? Okay. So if you multiply across, 1 on top, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Okay, and then for 60, a coin is flipped twice. What's the probability that the result is 1 heads and 1 tails? So if a coin is flipped twice, the probability that you get heads would be 1/2. What's the probability you would get tails? 1/2, so it would be 1/4.
Yeah, we should do 60 minus 62.
Yeah, we will. Okay, so there's a 1/2 chance of getting a heads. There's a 1/2 chance of getting a tails. Okay, so 61, they have 7 choices of dinner, but they can only choose 3 for their big day. The order is not going to matter. So if the order doesn't matter, that's where you can use the combination. Okay, which remember that is on our calculator. If you type in 7, go to math, under probability. And if it's C, that's when the order does not matter. P is for when the order does matter. And you can calculate that. And 62 will be the same thing. So the way that she chooses her 2 family members won't matter. For 63, what's the probability that a point chosen inside the rectangle is inside the shaded region? So what we have to find is the total area, and this is going to be the shaded area on top. So the total area of this entire rectangle is going to be 12 times 6, which is what? Yeah, 72, right? To find the shaded area, can you find the length and the width of this rectangle? Wouldn't the length of this still be 7? So this rectangle's area would be 14. For the triangle, the base of the triangle, see how this is 6? So this will be 6. This whole bottom part here. What about this part? Can we find out what this is? 12 minus 7, right? So it would be 5. 5 plus 7 is 12. So to find the area of the triangle, you have to do 1/2 times base times height. So the base is 6, the height is 5, and you will get 15. So then the shaded area is the 15 from the triangle and the 14 from the rectangle, which would be 29. So if we do 29 divided by 72, you'll get approximately 0.40. Okay, so for 64, for this one, it says what's the probability that a point chosen inside the circle is in the shaded region? So on the bottom is going to be the area of the circle. So the area of the circle is pi r squared. What's our r for this? 7. 2 pi r is the circumference. So this will be 49 pi. Okay, and then on the top, to find the shaded region, see how the shaded region is outside of the rectangle? So what we have to do is find the area of the circle and subtract the area of the rectangle. Well, we already found the area of the circle. It's 49 pi. What's the area of this rectangle? 20. 4 times 5, right? Okay, so then 49 pi minus 20 would go on the top, which is going to be a decimal, and that's okay. So you would use that exact decimal, it's 133.9, and then you would divide that by 49 pi. So I use that exact answer. Oops, sorry. And then your percentage that you should get is 0.87. Okay, and then I'll be here after school on Thursday for you guys. If you guys want to come in,